with respect to Earth. Got it? Please be very careful of over here because I'll get you again in the test questions wherein you will for the first time encounter what happens when you are talking vis-a-vis medium. So this will get you an idea how to distinguish medium from Earth. Got it here? So what is V naught over here? Velocity as seen from Earth. Got it?
Yes, sir.
Yes,
So
sir.
V naught is the speed of the observer as seen from Earth, and V is the speed of wave. V is the speed of wave, again as seen from Earth. Is it okay? V is the speed of wave, again as seen from Earth, from the ground. Got it, yeah?
Yes, sir.
Yes, sir.
So these are the respective speed when viewed from ground. We wish to see pattern of compression and rarefaction. Now, what do I mean by pattern of compression and rarefaction? Think about it. Hit the tuning fork on the bench. Hit the tuning fork on the bench. When one of the prong is set to vibrate, let me refer to one of the two prongs. Got it, yeah?
Yes,
Let
sir.
us set it to vibrate by making a hit. Got it?
Yes, sir.
So as the prong moves forward, what will it do to the air in front of it? Will it not compress it? Will it not compress it? It
Yes,
will
sir. Compress.
compress. So the air in front of it, as the prong moves forward, will get compressed. And when the prong is to take a backward motion, then the air will get rarefied. Got it?
Yes,
Got
sir.
it? Think about it. Moving forward, density of air is to increase. Why? Because air will get compressed. And when the prong is to move backward, and this movement is incessant, as you know, when it moves backwards, then what will happen? Then air in front of prong will get rarefied. Got it?
Yes, sir.
So as the prong moves back and forth, or keep your hand in front of your mouth and speak, dear. Keep your palm in front of your mouth and speak. Can you feel the difference in air? Can you feel the difference in pressure of air hitting your palm? Yes or no?
Yes, sir.
So basically what it is, as your tongue is moving back and forth, what it is doing to the air in front of it, it is compressing it and accordingly rarefying it. Yes or no?
Yes, sir. Yeah. Yeah.
Same goes for the prong or any sounding instrument, woofer. What will it do? It will move back and forth so that air gets compressed and rarefied, and accordingly you get the compression and rarefaction so as to gel with the frequency you are looking for. Correct?
Yes, sir.
Okay. So I'm taking a very simple case. And the case being air in front is getting rarefied and compressed. And what is that rarefaction and compression trail to you? Is it not a wave?
Yeah, yes, sir.
Yeah.
It
Yes,
is
sir.
a wave, right? Yeah. Trail of compression and rarefaction is to get you a wave formation, right, Krish?
Yes, sir.
Right, Pratyush? Vedant?
Yes, sir.
Okay. So you are getting a wave. And any wave is to merit speed, correct? Take
Yes,
any wave, be it transverse or longitudinal, it merits speed. You know about speed of wave, right? Yeah.
sir.
Which wave we are into referring over here? Longitudinal, correct?
Yes, sir. Longitude. Yeah.
What is speed of longitudinal wave? Gamma P by rho whole under the root. Agreed?
Yes, sir.
So this is speed of wave. Longitudinal wave. We have studied in detail about it. At length we did, right? Yeah.
Yes, sir. Sir, I just forgot, sir. I know what
Yeah.
gamma is. Can you just tell the name of gamma? Sir,
Gamma is adiabatic exponent. You will read more on it when we are in the portion heat. It is called adiabatic exponent.
No,
It
sir, it
is,
was there. Yeah, it was there in chemistry last year. So it was there in the tip of
yes,
the tongue.
yeah, but it is portion of physics. You will study this in thermodynamics when it comes to engineering. Third year of engineering, you'll study about thermodynamics in detail. So it is a part borrowed by chemistry. Got it? Okay, dear?
Yes, sir. Yes, sir. Yes, sir.
So gamma p by rho under root v is equal to gamma p by rho, and gamma has got value governed by Cp and Cv. We say gamma is equal to Cp by Cv. Cp, you know, is what? Heat capacity at constant pressure, and Cv heat capacity at constant volume. So let us refrain from going into the heat portion. We'll study in detail then. For now, we have V associated with longitudinal wave, right?
Yes, sir.
And this is what is V to us. Good enough. This is after of Laplace correction, correct? Yeah?
Yes, sir. Yeah.
Okay. Now, the person who is on Earth, not moving, is stationary on Earth. To him, wave is moving with what speed? V, correct?
Yeah. Yes, sir.
But to a person who is moving towards wave means towards source, opposite to the direction of propagation of wave. Got it?
Yes, sir.
So the person who is moving towards source, opposite to the direction of propagation of wave, as shown on board, what will he register speed of wave to? Is
Greater than V. Greater than V.
right? So with
Yeah.
respect to him, relative velocity of wave will be v plus v naught. Again,
Yes, sir.
relative velocity of wave will be v plus v naught. This is relative velocity, and relative velocity divided by wavelength, correct?
Yes, sir.
Relative velocity divided by wavelength. What will that get you? That will get you
Time.
frequency. That will get you frequency. No, not time, dear. That will get you frequency. Right?
Yes, sir.
V
Yes,
is
sir.
equal to f lambda. Correct, dear?
Yeah, yes,
Yeah.
sir.
V is
Equal to,
equal
yeah.
to f lambda. Right, dear? Yes or no? F is represented here by mu. Okay? F is represented over here by mu. We represent F by the symbol mu. What is mu to represent here? Mu is to represent frequency.
Yes, sir.
Now, please check. And these are the portions on which questions being asked. And these are the portions not dealt anywhere. I can say that unflinchingly without making any bones about it, and you will endorse it. You will endorse it when the portions are taken at respective institute. Fine, V plus V naught I wrote. I said that I'll be writing relative velocity and we wrote V plus V naught. What about wavelength? What about wavelength? Will the wavelength remain undetected? Will the wavelength remain undetected? First things first. What is wavelength? Wavelength is the distance between two consecutive compressions or two consecutive rarefactions, correct?
Yes, sir.
Yes, sir.
And Krish will ask me immediately, he will, in a way, I'm not taking offense. I'm saying he will, in a way, barge or cut me short asking, but when you talk of compression and rarefaction, then it is not to be represented by a line. Why? Because it happens in a confined volume, correct?
Yes, sir. Yeah.
Yes,
sir.
I'm Krish.
Yes, sir. Yeah.
Because you are talking of it getting compressed. So air is getting compressed. It will not get compressed to a line, common sense, right? Yeah.
Yes, sir. Yeah, yeah.
So it is to get compressed, no doubt about it, but it will have a volume to its merit, correct?
Yes, sir.
And that volume will see it getting compressed. Fine. And more it is going to front, more will be the rate of compression. Correct? Yeah.
Yes, sir. Yeah.
Tell me yes or no?
Yes, sir.
As the prong, think of the prong. As the prong is moving forward, it is compressing. Correct? Yeah.
Yes, sir.
It has compressed it now to its fullest. Correct?
Yes, sir. Yeah.
Now backward, rarefaction. Say yes or no?
Yeah. Yes, sir.
So we cannot reduce it to a line, correct?
Yeah.
It took
Yes.
some time for the prong to move forward and some time to move backward. So you are to merit volume to it, correct?
Yes, sir. Yeah.
Though counterintuitively, counterintuitively, I am showing the compression by a line. Got it here?
Okay.
That
Which
means
is
which point I am highlighting when the compression is to its maximum. Got it? Which point I am highlighting in the confined volume. The volume that Chris did ask me to take. In that volume, when the compression reaches its maximum value. Correct, Chris?
no, sir. I don't understand how you're visualizing the maximum part, sir. I
See,
understood your.
going forward, Krish, right?
Yes.
Compressing the air. Think of the air. Air was not moving, right? Yeah.
Yes, sir.
So it moves forward. It is compressing air in front of it or not?
Yes, sir. It's compressing. Yeah.
Now, when it has got to its extreme right, to you right, correct? To
Yes,
me
sir.
left,
Yeah.
correct? Then
Yes, sir.
air has got compressed to its maximum, right? Yeah.
Yes, sir. It is compresses maximum. Yeah.
Air started compressing the moment prong was moving forward. So compressor has started, compression initiated the moment prong started moving forward. Correct? Yeah.
Yes, sir. Yeah.
Yes, sir.
Was getting compressed and it was continuously getting compressed till the time it got compressed to its minimum, right?
Yes, sir. Yeah.
Now,
Yeah.
as the prong is moving, wave is not remaining there. Wave is also moving. Are you getting Krish?
Yeah. Yeah. Yes, sir. Yeah. Now I got
So
it.
prong is moving, wave is also moving, but the prong is moving at the faster rate, right, Krish?
Yes. Strong is moving faster. Yeah.
So prong moves forward, compression got started. But when will the compression be maximum? When prong is to its extreme, correct?
Yes, sir. Yeah.
So that is the point which I am referring to by a line. Got it? Yeah.
Okay. Yeah. Yes, sir.
Compression will be represented by volume, no doubt about it. But there will be one line which will represent maximum compression in that volume, correct?
Sir.
That line is what I am referring to as compression. Got it, Krish?
Sir. Okay.
Is it okay?
Sir. It's okay, sir.
Okay. So this is a compression. This is also a compression. This compression was generated at what time? At some time. And this is generated as of now. Got it?
Yes, sir.
So lambda is the distance. And what we can write lambda to be V into tau. What is tau? What is tau? Time period. Time period of what? Time period of tuning fork's vibration. Got it?
Yes.
In that time, in one complete vibration of tuning fork, the wave moves forward and forward by what distance? Lambda. Got it?
Yes, sir.
Yes, sir.
That is what to us is speed of wave multiplied with time accorded to it. Which time? The time period of tuning forces prong vibration. Got it?
Yes, sir.
Okay. So we got the compressions. Now my question, find we wrote V plus V naught. What about lambda? Will not lambda change, or lambda as seen by observer who is running towards the source and as seen by observer who is stay put on earth will read the same? Tell me dear. Will lambda 2 change? Will lambda 2 change, or lambda will read the same? Now important point to note, when lambda changes, then it is a given that source is in motion. When lambda changes, then it is a given that source is in motion. Rephrasing what I have said, lambda will change when source is in motion. Till the time source is at rest, lambda remains the same. In this case, source is at rest or is in motion?
It's in motion with V.
Oh dear. Source is not in motion. Observer is in motion. When did I say source is in motion? I didn't write speed for it. Correct, dear? Check the heading. What is written? Check the heading, please. What did you write?
Yeah, yes, sir. It's observer is, yeah, source is sounding a frequency. It's not in motion.
Yes. So, source being at rest, lambda will remain the same. Correct, dear?
Yes, sir. Yeah.
And as lambda remains the same, we get V plus V naught divided by V into tau. Check it out. V plus V naught divided by V into tau, which is to get us V plus V naught by V, and 1 into tau, 1 by tau is nothing but natural frequency of tuning fork, right?
Yes, sir.
So tuning fork is sounding a frequency F naught or mu naught, and mu is the frequency heard by the observer who is moving towards the stationary tuning fork, correct?
Yes, sir.
Tell me, taking a cue from here, tell me if the observer is to move away from tuning fork. If the observer is to move away from stationary tuning fork, got it?
Yes, sir.
What will be the change in the equation I have written?
The V minus V naught by V into nu naught.
V minus V naught, this time relative speed will be, or velocity will be V minus V naught, lambda remaining the same. Thereby what we'll get over here? V minus V naught by V into F naught, correct?
Yes, sir.
Yes,
Or
sir.
V minus V naught by V into mu naught, correct, dear?
Yes,
Yeah.
sir.
Recently, there was a phenomena observed by Bangaloreans, and that was of sonic boom. Recently, there was a phenomena observed, or you can observe this phenomena, very frequented phenomena this, in the Air Force defense diaspora, because the jets generally move with speed more than 330 meter per second, which is what is speed of sound. Got it, yeah?
Yes, sir.
Now, Krish said, when I asked Krish, he did say, sir, I will write V minus V naught. He is right. He will write V minus V naught. But V minus V naught will hold merit till the time V is greater than V naught, correct?
Yes, sir.
Yes or no, dear?
Yes, sir. Yeah.
When will the wave reach observers' ears? When will the wave reach observer ears? Mind you, now the observer is moving away from sounding source, correct?
Yes, sir.
Wave is following observer. With what speed? V, correct?
Yes, sir.
So will it be possible for wave to match with what observer is trying to negotiate in time t? Will depend on whether is V greater than V naught or less than, correct?
Yes, sir.
If V is greater than, we have an equation at our disposal, which you have written in your notebooks, correct?
Yes, sir.
What if V is less than V naught? What if V is less than V naught? If V is less than V naught, that means when you are moving with speed more than the speed of sound, got it, yeah?
Yes, sir.
Then we get a phenomena which is called sonic boom. What will happen over here? Here, sound will get compressed and you will hear it as a thud. Is it okay? Sound will get compressed because you are getting wave after wave. You are beyond it. So you are getting wave after wave, and this phenomena you will study in greater detail when we'll be dealing with sonic booms. Just write it down somewhere. SONIC BOOMS, sonic booms. This is what you get, and you hear sound as thud. You will hear a large sound in no time. Got it, yeah?
Yes, sir.
Yes,
Anyway,
sir.
let's not go there for now. Now we are moving with speed which is much less than 330 meter per second. So for us, frequency registered is V minus V naught divided by V into mu naught. Got it, yeah?
Yes, sir.
Yes, sir.
Okay. So in one case, it is greater by what ratio? Please look at this equation. 1 plus V naught by V. Correct? We can write it
Yes,
as
sir.
1 plus V naught by V. These questions are asked in everyday kind of examination. That's the reason I am dwelling on it. 1 plus V naught by V. So it is greater by what factor? V naught by V. Correct?
Yes, sir.
And the other one can be written as 1 minus V naught by V. So lesser by what factor? V naught by V, correct?
Yes, sir.
Okay, so we get over here by what factor, by what percentage it is higher or lesser. Mind you, this is for the case when source was at rest and the observer moving either towards or away from stationary source, correct?
Yes, sir. Yeah.
So in this case, numerator did change, denominator was unscathed.
Yeah. Yes, sir.
Okay, let us take the second case. Write down. Source is moving. Source is moving towards stationary observer. Source is moving towards stationary observer. Draw a schematic diagram. Draw a schematic diagram. Subsequently, formulate frequency equation. Subsequently, formulate frequency equation. Got it, dear?
Yes, sir.
Now what we are to do? Please take a note. This is tuning fork. This is compression C1. and this is the compression at the position of stationary observer. Got it, yeah?
Yes, sir.
Okay. Now, source is moving or is made to move. Got it?
Yeah. Yes, sir.
Source is made to move. And source is made to move with what speed? Vs. Got it?
Yes, okay, sir. Yes, sir.
Tell me, when according to you, this source will be ready to exhibit another compression.
Sir, can you
When
repeat the
according
question?
to you, this source will be in a position to animate or permeate another compression.
So when it's vibrating,
When it's vibrating, it is through and through vibrating there. And you know, compression between two compression, what is the distance that I have taken? It is through and through vibrating. So my question doesn't hold sense in a way. Doesn't hold sense. Why did I say so? Because it is a continuous trail of compression and rarefaction. We know that. But I have
yes, sir.
stated at the top of this discussion that I will be representing it by a line. Did I?
Yes, sir.
I see it or not? Did I
Yes, sir.
see
You
it or
did.
not at the top of the discussion that I'll be representing it by a line? Correct, yeah?
Yes, sir. You did, sir.
And I made you know that the distance between line being one wavelength.
Yeah.
Distance
Yes, sir.
between two consecutive lines being one wavelength. And what is a wavelength? Distance traveled by wave in a time period. Correct?
Yes, sir.
And I also told you that this time period is to relate with prong of tuning fork, right? Yeah. So
Yes,
now
sir.
you can place two and two together and get me the answer. Please start exercising your brains. Get me the answer that in one time period, what is the time after which tuning fork will permeate another compression C2? What is the time after which tuning fork will permeate another compression? Come on, dear. Very simple ask. This doesn't qualify an ask. This doesn't qualify a question. Come on, any one of you. What time it will animate another compression? You know when it is animating compressions, dear. You know what is distance between C0 and C1, don't you?
Yes, sir.
So, what is distance between C0 and C1? Distance between
It's
C0 and C1 is
lambda.
wavelength, correct?
Yes,
Yes,
sir. Lambda.
And one wavelength means what to you? Speed multiplied with time, right? Which time? Which time? What is tau there?
so
What
this
is
one.
tau there? Maybe saying yes, sir, will not do. What is tau there? You have to understand, and you can understand only here. Let me tell you. Make light of it, and later you'll not be able to solve questions. Tau, what is tau there? Try to understand. What is tau there? I
The
told
time
you what
period.
is tau there.
The
Time
time
period.
period.
The time period.
To tau. Ah, yes, Krish.
You told it was time period.
Time period of what?
This one wave.
No, it is not time period of it. These are the points you don't understand, and then these are chink in the armor later in questions. Tau, I told you, is a time period of vibration of tuning fork. What did I write 1 by tau? I wrote 1 by tau as frequency, right, dear? Frequency of what? Natural frequency of tuning fork or organic frequency. Didn't I tell you?
Yes, sir. You told that. Yeah.
Yes,
Then
sir.
please be very careful. Tau is the time period of the prong of tuning fork. Got it, dear?
Yes, sir.
And V into tau therefore will be, because wave is moving with V speed, but wave got what is speed? V from where? I'm not concerned. I'm concerned with wave has got what time elapsed. What is the time accorded by tuning fork? Because tuning fork will produce another compression in what time? In time tau. Yes or no?
Yeah. Yes, sir.
So what is the time accorded by tuning for to the wave? Is tau. Therefore, in tau time, C naught will travel what distance? V, the speed with which it is moving, into tau. Correct?
Yeah. Yes, sir.
Now tell me, C1 is as of now son. What will be the time? What time you require for C2 to show? Come on, all of you. Now I want tuning 4 to generate the next compression. Which compression? The compression which I will mark C2. Is it okay?
Yes, sir.
So tell me in what time will it generate? What time from now? All of you now. What time? What is the time required?
So 1 second, sir. I'll just leave and join back. So 1 second.
Yes, Kadesh, sorry, Krish. Pratyush, tell me what is the time required, Vedant?